everyone, myself Dr. Babu. Currently I was working as an assistant professor in the Department of Electrical and Electronics Engineering at the University-Surampalem. Today in this section, we are going to discuss about three-phase power measurement using 1 wattmeter method. In the previous classes, we have discussed about three-phase power measurement using 3 wattmeter method and 2 wattmeter method. In this session, with the help of 1 wattmeter, we will be going to see how we will be measuring the power in a three-phase circuits. So, coming to the circuit diagram, that means setup diagram, this is a three-phase circuit where R, Y, B are the phases with neutral point and is a star connected load where we have used 1 wattmeter method. Generally, this 1 wattmeter method is used in balanced system. As we have discussed earlier, the wattmeter consists of 4 terminals. They are named as M, L, C, V. Okay, where M means mains, L means connected to load or line, C means common, and V is voltage. In general, in almost all the circuits, this MC will be in short circuit condition. And M and L are called as current coils. Okay, that means these are connected in series with the load or source. Whereas C and V are called as pressure coils. That means these are used to measure voltages across the load or the source depending upon the necessary condition. That means a wattmeter consists of 2 coils. First one is current coil which measures voltages. This current coil is connected in series with the load or source, whereas this pressure coil is to be connected in parallel with the source or load. And coming to the setup diagram, this 1 wattmeter is connected across the 3 phases in such a way that it will measure the power that is flowing through the 3-phase circuits. Okay. The major disadvantages is it produces large error. Okay. That means in the measurement of power, this 1 wattmeter method is produces a large amount of error when compared to 2 and 3 wattmeter methods. And moreover, this is not suitable or suggestible because of its error ratio. Okay. So, from this you can see the circuit diagram where star connected, okay, one can observe from this, let this as R phase and this one as B phase and this one as Y phase and this is the neutral terminal, okay, and this will be as Z impedance ZRN and this one as Y impedance ZYN and this one is known as B impedance ZBN and the voltage across this is VRN and this one is VBY and across V R and Y is VRY. Okay. In some of the textbooks the notation may be ABC. Here also you can observe it is in ABC. Okay. But here as the previous classes we have discussed about RYN, here I have drawn in the form of RYN. And I have stated that the 1 wattmeter method, with the help of this 1 wattmeter we are going to measure the power in 3 phase. That means this 1 wattmeter method having 4 terminals, this should be connected across all the respective phases. Okay. For that, here I am connecting pressure coil, that means ML across the phase RRA. Okay. That this one be B and this one be C. Okay. Across phase ARR, I am connecting the current coil M and L. That means let the current flowing through this M and L is IA. Okay. Now there are another 2 coils. Among these 2 coils, I am going to connect the pressure coil. Okay. Okay. If you observe, this means C and V. But here this M and C are not connected, because if you connected M and C means the voltage value will be differing. So for that purpose, in order to get the exact value, we are connecting this C to B phase and V to Y phase. Okay. This is the general circuit diagram. Now if you observe, this means the current coil, current flowing through it is IA and the voltage across it is VA, whereas in pressure coil it is connected across B and C phases, that means VBC. Okay. Now I am arranging this one and now I will be going to draw on the phasor diagram. So here the phasor diagram is, with the help of this phasor diagram only, we are able to attain the phase angle difference between the voltage and current. That means here the voltage is VBC is the voltage and the current is IA. Now we need to establish the angle or calculate the angle between VBC and IA. Okay. Let us draw the phase diagram. So first instant I am drawing the three phases VA, VB and VC. Okay. Let this be VA and VA, VB, VC are 120 degree apart. This is VB, whole angle is 120 degrees and this is VC, this is 120 degree and this angle is also 120 degree. Now we all know that the in phase A, okay, this is the phase A, right? So current flowing through it is IA. This VA and IA are lag. That means this IA lags VA. So here I am drawing the IA. Okay. So the angle between VA and IAB, let it be phi. That means this is the phase angle. Okay. The angle between VA and IA is phi. But we need to establish the relationship between VBC and IA. Okay. Now from the circuit diagram, if VBC is given by, okay, VBC is given by VB minus of VC. See here, VBC is given by, this one is VB N and this is minus, okay. Therefore, VB is given by, here I am writing it, see, VBC is equal to VB minus of VC. That means, see here, VC is in the upward direction, this part, VC is in the upward direction, okay. This is minus VC. So now the phase angle will be, this one will be 60 degrees and this one will be 60 degrees, okay. Now if you observe, this one means VB minus VC is VBC, okay. So here I am drawing the resultant one, VBC, okay. This is VBC. Now after drawing VBC, the angle between VBC and VB will be 30 degrees and this one is also 30 degrees. But we need to draw or establish a relationship between this VBC, and IA. Okay. I need to establish the relation between this VBC and IA. So if you observe this one carefully in the sense, okay, from here to here it is 30 degrees, right? Angle between VBC comma IA, that is from VBC to minus VC it is 30 degrees plus and minus VC to VA plus 60 degrees. Okay, but here some phi is there, see, that we need to subtract, that means it will be 90 minus phi. Therefore, the angle between VBC and IA is angle of 90 degrees minus phi. Okay. Now, we need to write the power equations. Okay. The power is given by the total power P is equal to VBC, IA and angle between them it. Okay. The angle between them is angle of 90 minus phi. Therefore, the power measured P is equal to VBC, IA cos of 90 minus phi, which is nothing but VBC is nothing but V line current and IA is nothing but I line current sin phi. Okay. And in order to get the reactive power Q, Q will be root 3 times of VLIL sin phi. Okay. Therefore, the current active power is VLIL sin phi and the reactive power is root 3 times of VLIL sin phi. Coming to the summary, this one wattmeter method, we can use it for 3-phase 3-wire systems or else 3-phase 4-wire system also. Okay. And this power, as we are measuring with the help of one wattmeter, you can simply multiply with 3. The main assumptions for this 3-phase 1 wattmeter method is it should be balanced load and equal phase voltages and phase currents. And the major drawbacks are this is not suitable for unbalanced loads and it requires balanced conditions. And this is the most important point is this is very simple and efficient method, but it shows a little bit, not a little bit, margin of error. With this single wattmeter, power P is given by VL IL sin phi and reactive power is given by root 3 times of VL IL sin phi, where the units are VAR. Okay. So, with this we have completed the power measurement using one single wattmeter. Thank you.